So I'm going to try to give a brief explanation of my setup. My 15 panels mounted on a ground mount, which I built myself out of just ordinary steel framework material, mounted on 4 posts. As you can see, they are embedded into the ground with about 1 cubic meter of concrete on each one, and adjustable with this setup, which is not exactly what I wanted, but unfortunately in Europe I couldn't find the genuine struts to adjust them, so I had to modify this jockey wheel from a trailer with a bush so that it can slide without major friction, and with a spherical joint inside, hiding inside this bracket. The framework is just, as I said, a galvanized steel mounted on bearings, which I'll show you in a minute. And there is a tension cable, which you can see here, which is there in order to stop the center element from flexing too much, especially under the weight. You can adjust, of course, the tension of this cable. The 4-post concrete embedding elements are joined by this ridge, which is reinforced with steel, mainly to support and to prevent the soil from moving around. All cables are running inside trunking, and they end up in this box, which is meant to be a combiner box, but it's not actually combining anything. It's actually acting as a delivery box, which delivers the power from the 3 strings, each one comprising of 5 PV modules, delivering around 11 amps each at a maximum voltage of 250 volts. Of course, inside we have the usual surge protectors and fuses, followed by the breakers, and finally by the 3 isolators, just in case you need to isolate the line between this element and the solar shed. These panels are facing south, and let's go and have a look at these bearings. Usually this type of framework is mounted with a bolt going across, a plain bolt, but I decided to actually put a bearing in there, which is a little bit more engineering. Quite happy with the system because it's very strong and it should last really for many years to come. The 4 struts need to move slightly during the adjustments, so each is provided with these slots and one locking mechanism with a handle, which can be used every time after repositioning. The ground connections are there to remove any static electricity that, especially in this area with the winds, can certainly add up. As I was saying, all the cables are running underground down to this solar shed, which is not exactly completed yet because the left-hand side is going to house my 2 compressors and my generator, whereas on the other side we have the complete system producing the energy at the moment. I've also installed 5 more panels on top of the roof of the shed, which in fact, if we can climb up on my building, which is under construction as well, you can see better. This framework is also adjustable, but I haven't quite yet fitted the actuators in order to raise the panels towards the west during the afternoon hours, something that I will be doing in the near future. Going down again, we can now see what's inside the solar shed. This is the whole system with the twin inverters. This is one of my Macintosh, which I always keep here just in case I need to adjust or modify or indeed update any of the firmwares. Everything that you can see from here can also be seen online anywhere from anywhere, I should say. So I can use the phone, I can use any other computer indoors, or I can actually be flying to Asia and still check on this system. I can see all the modules, I can see all the graphs, and also I can keep an eye on any potential alarms. I can also see the same image that I would get from my console, which is fitted here on the main panel, what they call the power wall. And as I was saying, there are two battery chargers or MPTTs, which are collecting from these two cables the energy coming from the solar modules, and they are delivering it to the distribution box, which then in turn takes it to the batteries. After having been through this one in the middle, which is a shunt, verifying power coming or going from or to the battery. There are currently only two batteries, but I built a system in order to allow for a maximum of 4 batteries to be installed. As I was saying, the energy stored in the batteries goes then through to the distribution box, which in turn takes it to the two inverters. The reason why there are two inverters is because they're running in parallel, because each one of those is rated for 5,000 kilovolts, basically in the region of 4,000 watts each. So by having them in parallel, I can push up to 8 kilowatts of power continuously. And this is finally the real combiner box, where the 3 strings arriving from the previously seen delivery box are now being combined into one line and joined with the line coming from the 5 PV modules on the roof. Finally, the consumer box for the shed itself, with some breakers for the utilities and also some switchovers, one for the earth, which I will explain later, because I need to isolate the ground electrode from the generator end here to the one of the building of my house. There is a switchover between the grid and the photovoltaic, allowing to automatically disconnect the photovoltaic line and connect the grid in the event that there was a failure of my own system. There is also another switchover which is designed to be used in conjunction with the generator, which, as I was saying, is going to be installed in the other side of the shed. This is where the dividing wall is going to be installed. And here we can see the two batteries installed for the moment. One of them was actually purchased, ready to go. And the second one is the one I built last winter, which is built out of 16 304 amps cells with a Seplos BMS. And the second one, I've just ordered all the materials and the components will be built next winter when I have more time. This battery is producing in the region of 15 to 16 kilowatts, whereas the small one is only a 5 kilowatts unit. Altogether, by the time I'm finished, I'm going to have 15 plus 5, so about 35 kilowatts of energy storage. Finally, this is the back of the power wall, the rear end, where all the cables are situated. A little bit in a mess at the moment because I'm running some temporary Ethernet cables, but everything will be then duct inside those trunking as usual. We have 3 bus bars which I made out of aluminium and helicoil inserts in order to have all threads. The first one at the top is the photovoltaic bus bar, which is combining all the units for the system, which is directly connected to the ground electrode. The second one on the right is the earth bus bar from the grid. And lastly, the one for the delivery to the buildings, with obviously all the grounding conductors for that purpose. This way, if the bus bar on the right is being used because we're using the grid power, then the earthing electrode of the PV system here is disconnected from the main earthing conductor coming from the grid. Vice versa, if I am using the photovoltaic system, the ground from the grid is disconnected from my system. So the two ground electrode can never suffer from any potential differential. Something that can happen if there is, for instance, a lightning striking the earth, generating a large gradient, which surprisingly enough can reach differentials of up to 20,000 volts between two rods being positioned at around about 20 meters of distance from each other. As I said, the whole thing is still under construction. The auxiliary generator will be installed next to my two compressors and an air conditioning unit, which is arriving possibly next month, in order to keep a constant temperature inside the shed, so that both humidity and temperature can be constantly monitored and maintained reasonably close to what they should be.